Okay. The best thing is don't draw any person or motorbike or any system, or whether it is a plane. Don't draw. Only consider this whole system as a straight line.
Okay.
Mark all the forces
Okay.
like R1, R2, and mg. Understand? And from the
Yep.
person, it's like simple mg. So using those things and just begin to mark the distances like d1 and d2, d3. Identify the what pivot. So one times you have to get this one as the pivot and consider this force. Or you may just
Mm.
get the rear wheel as the pivot and consider the force around that. You can choose any point in the system because it's in equilibrium. No? Equilibrium means at any
Yeah.
point the resultant net force is what? Net moment is zero. You can take any point as the pivot and find out the forces around it. Sorry, moment around it. Got it?
Yeah.
Okay. The other way is sometimes you may have to draw an L. You might be wondering what, because this is only about in 1D, one dimensional, the previous one. There might be
Yeah.
any other forces in 2D. 2D. How to deal with 2D? Don't worry, we don't have to deal with the 3D thing. There was a
Mm.
very nice question in a very recent paper. I can't remember the year of the paper.
Yeah.
There is a hook, right? A cord
Mm.
is hang on this hook. It can be any other mass even. And there is a pivot point. And there is the certain what screw, which is the one keep it tightened. So now the entire system, the hook is going to rotate around this point. This is where the pivot. And this screw keep it holding back to the what wall, holding to the wall.
Mm.
And this one acts certain force downward, which is mg, the weight. Okay, now this is a extremely different thing. How would you find the moment? You can't get this to a simple line, one line. No, you can't. But you can get
Yeah.
this force to this type of L-shaped object, right? This is where the pivot,
Yeah.
and
Yeah.
this is where the force. This is where the
Yeah.
downward force
Yeah.
of weight, right?
Yeah.
This is an L. Can you understand?
Yeah.
If you find any of these 2D thingy, draw an L and mark the forces.
Yeah.
Sometimes you may have to draw like multiple stuff like, wait, likes of a Benz logo. One post may act
Yeah.
from here, the other from here, the other one. Don't worry.
Mm.
Mark the pivot point. This one is clockwise. This one is anti-clockwise. This one is anti-clockwise. It's like moment one, moment two, moment three. So what to do? M1 equals to M2 plus M3. Isn't that?
Yeah.
Don't worry about what is it. So consider the object with lines. Always maintain and represent all by line. That can be a very single line. That's the most common type. Or two lines or three lines like this. Got it?
Yeah.
Okay. So shall we try a question?
Yeah.
Try the first one. Um, I'll give you like five minutes because this is a really simple question.
Yeah.
Maximum 5 minutes. Okay. Have a good look at here. The gardener used a trolley to move a paving stone. Paving stone is here. A force meter was attached to the handle of the trolley, right? It may act like force of F, just mark it. And the gardener recorded the following measurements when the trolley was set at the rest in the position shown in the diagram, right? Mass of the trolley and paving stone is 18.5 kilograms. The whole thing together, right? Looks on.
Yeah.
Okay. So it's like a whole thing together is equals to 18.5 G, right? You can
Yeah.
take this point as the pivot. Now it asks what? Determine the length of the center of gravity of the loaded trolley from the wheels. Got it?
Yeah.
Right. From the wheel. What is the total length of the trolley? It is some 97 centimeters. Okay.
Yeah.
Right. Around the pivot point, remember that you always need to get the force like this manner. There is a force in the upward F, there is a force in the downward Fg, and the total length from here is like 97, right? This
Yeah.
force is 50. Mg is, you know that, 18.5 G. Only thing you don't know is this length, isn't that?
Yeah.
Now we have to remember another thing. The forces should be perpendicular to the what direction of apply. So shortest distance, this is what mg is here. If the angle is like theta, angle is not given, but it is the angle. This angle is also going to be theta, isn't that?
Yeah.
This one, when you get this one, this is also going to be theta, f cos theta, and this one is mg cos theta. Now I can bring this to this type of position. Pivot, the distance d, I don't know. The force is what? 18.5 G. And in the cos theta. Cos theta, the upward thing is what? 50 cos theta sin times what is the distance? 97. Yeah. Now you can apply it like this. How? The anti-clockwise equals to clockwise. Isn't that?
Yeah.
So what is the anti-clockwise one? This one is anti-clockwise, this one is clockwise. My anti-clockwise is 50 cos theta times 97 equals to the what? Clockwise one, 18.5
18.5.
times 9.81 times the distance d. Really easy, ne? Sorry, this one is cos theta. I forgot cos theta.
Yeah.
Now cos theta and cos theta cancel, so
Yeah.
you don't want to worry about that now.
Mm.
What is d? 50
Uh,
times 97 over 18.5 times 9.
404.3.
400? What?
Yeah. 15 to
15.
No, my bad.
It should be smaller than that one. What is it called? Total length 97.
Yeah.
What is the answer you get?
26.7.
Ah, 26.7 centimeter. Can you understand how to deal with this type of question now?
Yeah. So can you explain the angle part again?
I will explain.
The cost.
Let
How did
me teach you that in the next page. So all the time we get the forces. Those are perpendicular to the what? Forces are perpendicular to the distance, right? If we get any other component, tension like T and theta, I can't just use T. Can't use.
Yeah.
What do I have to do? I have to resolve this and get this one as T sine theta. And this one is T cos theta, not with T. Understand? Always want to get the perpendicular component to the path. Axle. Okay?
Yeah.
Got it?
How do you know T sine theta and not cos theta?
Why? Because see, there is the theta here. The perpendicular component is T sine theta. Don't you know how to resolve the problem? Don't you know how to resolve? Huh? If there is a force like this, don't you know how to resolve this one? The component of this T in contact with the angle, the close side is known as what? T cos theta. The open side, the other one is known as T sine theta. Got it?
Yeah.
Always get the component which is imperpendicular with the force. Understood?
Yeah.
Good. This one is an explanatory one. So firstly, let's do calculatory one. Shall we try this sprinter question? Because this one is not that much complicated. We have to do something not that complicated, then go for the complicated one.
Yeah.
Firstly, start with that. There are many millions of complicated questions after.
So what question number?
With the sprinter, okay. A sprinter is shown in the before race, stationary in the set position, as shown in the figure. The F is the resultant force on the sprinter's fingertips. Okay, is disconnected again. Give me 1 minute. Problem solved. Okay, here, what do we say? Y on foot like 180 Newton, right?
Yeah.
And W is 250, and X is the vertical reaction force on her back foot. The vertical reaction, right? This one is known, is like 180, right? The weight is 520. And the F is the what? Force on vertical reaction force on backward. Okay. Resultant force on fingertips. Okay. Now calculate the moment of the string. Moment of the string's weight W about her fingertips. Right. Only the weight. Right. Moment
Yeah.
of the sprinter's weight. Right. It's a very simple question. As I told you, you just need to draw the straight line here on the fingertips. F. And this one is created by W. And the distance is 0.26 and the force. What is the moment? Moment is 520 multiplied by 0.26. And is that how you did?
Yeah, that's great.
Yeah. If you did, wait, I'll get the answer. 520 times 0.26. And the answer is like 135.2.
Yeah.
Okay. In Newton meters. Right. The next one is like by taking moment around her fingertips, calculate the force exerted on her back foot. Need to do this one.
Second one, I did halfway, but
Okay. There is a very simple logic. It appeared to be like a hard one. No. I told you, no. You have to do nothing but what?
draw straight line and
Draw a straight line. Consider the fingertips as a what? Pivot. Right? This one is the pivot. So you don't want to know about the force, right? Any force on the pivot, we don't consider, right?
yeah,
In case of moment, what is the equation of moment? Force
force
multiplied by
into open
distance.
field.
Yeah.
Yeah,
In this case, the distance is 0. So no moment is applied on the pivot by any force on the pivot. Got it?
yeah,
Okay. Now mark the other points. Firstly, mark other points. What is the other point here? It's like 0.26. Right?
yeah,
The force is W weight. Got it?
yeah.
So what is the other force here?
That's why.
0.41. And what is the force of that one? 180
That is 180.
Newton. Got it?
Yeah,
And there is another force. First we mark the distance. What is that distance? We mark, sorry. The next one is this force, X. You don't know.
yeah,
But the distance is 0.63 meters. Got it?
yeah,
Now mark whether anti-clockwise or clockwise. This force is a clockwise.
yeah,
The other two forces are anti-clockwise. Remember the vector sum of what? Moments around pivot is 0. So 0 equals to what and what? 520 times what? 0.26. Or you can just use this answer itself because we just found the moment of that. It doesn't matter if
yeah.
you directly use that one even. No problem. Minus, what is the other one?
180.
180 times 0.41 times what? It looks ugly. Come to here. 0 equals, what is the answer? 135.2 minus, what is the next one? 180.
180.1.
Yeah. What is the distance here? It is, yeah, 0.41 plus any force, I don't know, times 0.63. Got it?
Yeah.
Now it becomes 135.2 equals to 180 times 0.41 plus x times 0.63. So x times 0.63 equals to 135.5 minus 180 times 0.41. So how to find out x? X equals to 135.5 minus 180 times 0.41 divided by 0.63. This is the way. Understood?
Yeah.
Can you explain me now?
Yeah. So since they've asked from, can you go up a bit?
Okay, I will scroll down and minimize the size. Okay.
So since they've asked moments about fingertips, we have to
Yeah.
take all the way from that to, we have to consider that as the pivot, and from that onwards, all the forces until the back foot. So we take it as a horizontal line, mark the clockwise and the anti-clockwise,
Hmm?
and then since the moment is zero at force, because this distance is zero, we
Yeah.
have to equate zero equals to all the forces times their distance. So
Yeah.
the moments about W minus moment above y plus moment about x. Then
Yeah.
we can
No,
find
no. Wait,
the
wait, wait,
force.
wait, wait, wait. I made a very terrible mistake here. I have to put a bracket around, right?
Yeah, so that we have to take as one, no?
Yeah, yeah. So, or you
Right.
can directly use this method. What is the other method? You can directly use like the other thing called anti-clockwise equals to clockwise. CW equals to CW, right? That's the
Yeah.
easiest method. Like 180 times 0.41 directly equals to what are the clockwise? So 135 point. So there is another anti-clockwise. I sorry. Plus
X times
x times
0.63.
0.63 equals to 135.2.
Yeah.
Now you can just get the answer for this one and subtract it from here. You can do it like step by step. So first find out this answer. 180 times 0.41.
73.8.
73.8
8.
plus x times 0.63. You can write like 135.2. Now subtract x times
Yeah.
0.63
61
equals to
point.
70.52 minus 73.8. What is the answer you get?
61.4.
Yeah, x times 0.63 is 61.4.
Yeah.
X equals to 61.4 divided by 0.63. Okay.
97.4. 6. So
Okay.
97.5.
Okay. Now, can you understand the way how to do it?
Yeah. One second, I copy. I'll write it down.
Okay. Here you might have done some mathematical error. Ah, no, we didn't get the finalized answer. Eh? Don't worry about copying this. I can provide you the board drawing as a PDF. You can keep the space.
Ah, yeah. Okay. We can do it.
Yeah, we can save our time.
Yeah.
Nowadays, you have to battle with your timing, not with the
Yeah.
knowledge. Mm.
Yeah.
Okay. Now I hope that you understood how to deal with. So shall we try
Mm.
another bit, just a bit hard one?
Yeah.
This one, question number 4, is not that extremely hard, just a bit hard, right? And after that, let's straight away go for momentum or force or whatever you want.
Mm.
Now start.
No.
Give you like 10 minutes for this one. Maximum.
Yeah. I'm done with part A.
So that means you couldn't. Huh? Okay.
First one I did, part B I do the line and I wrote the forces.
Okay.
And then
A
after that
portable.
I know. Huh?
What did you say?
No, so I know the angle. It's 15. No, that's all I identified. But then now I don't know how to calculate the minimum force.
Okay. A portable basketball set as a base and post arrangement like this. And the post arrangement consists of a post, backboard, hoop, and net. Right. The base has a capacity of 85.0 liters. You can just weigh the stuff using water. So that the maximum weight
Yeah.
of the base is like about 870 newton. 1 liter is equals to 1 kilogram. So the base is empty. Mass of base when empty is like this much, right?
Yeah.
Okay. What is the total weight? Weight equals to weight of the base plus weight of the water.
Yeah.
Right. So it is like what 3.5 times 9.81 plus 85 times what
9.8.
9.81. What is the answer you got for this one?
868.1. So it's
86.
8.
What is
868.1.
uh,
No, sir, 868.
868 Newton. Yeah, this one is approximately closer to
870.
870 Newton. Huh?
Yeah.
The next one. B. Due to large area of the backboard, the basketball set may topple over when the wind is low. Now see, when there is a gust of wind, so it may just get toppled like this, right? So weight of the post arrangement is applying here, and this one is the pivot point now, and this one is the weight of the base. Weight of the base create what? A clockwise moment, while weight of the post arrangement creates an anti-clockwise moment. Can you understand it?
Yeah.
Okay. Now this one is also similar thing like the previous. But I would think an L shape
Yeah.
structure, isn't that? So, Dirkshan,
Yeah.
isn't that?
Yeah, sir. That's what I do. L-shape line.
Hmm. This is also like an L shaped structure. So first we draw the L shaped line like this. Mark this one as the pivot. And there is a force which is directly downward, and the angle is marked as 15 degree. Right. This force is like F wind and the weight of the post and weight of the base. Right?
Hmm.
Okay. Now I told you one thing. Whatever the shape, it doesn't matter. You have to get the force which is perpendicular to the line of action. So this angle is also going to be 15, isn't that?
Yeah.
Right. This one is what now? WB. WB what? Cos 15. Can you understand?
Yeah.
In this part, again, the perpendicular component FW cos 15 again. Got it?
Yeah.
Now here, this angle is also 15. So there is a one component down along the plane. Sorry, post. We don't count it because it is just on the pivot. But the perpendicular thing, what is it? WP sine 15 is the force. Got it?
Yeah.
Okay. What is the distance from here to here? It's like 2 meter. And there is a 0.4 from this point, 0.4 meter. Now I mark all the stuff according to vector analysis now. Now I can remove these forces. Now no need. Because I got the relevant components. Once I get the components, it may look like this man. Right. I can also now use this one as a kind of firm one like this. Because I resolved. One is what? FW cos 35. Right? Other one is WB cos 15, not 35. Cos 15. The other one is what? Here?
WP sine.
WP sine 15. And the distances we know, like 2. From here, it is like 2.4 now. Now this one is like 0.45. Okay. Now identify. Clockwise, anti-clockwise, anti-clockwise. Now the simplest method is anti-clockwise equals to clockwise. Let me minimize the size a bit. Okay, what are the anti-clockwise ones?
FW
the minimum force of FW. Post alignment is also given. FW times cos 15 times 2.4 plus F 27 sine 15 times 2 equals to the clockwise one. What is the W base we just found? 868, huh?
Yeah, 868
times 0.45. Got it?
Yeah.
Now subject this one and get the answer. It's no longer physics.
868 into 0.5 cos 15, no?
Yeah. I forgot that. Yeah, good observation. That's it. Cos 15, I forgot. Here it's like cos 15. Right?
Yeah.
You can't cut it off like the previous one because there is a sine component also. Apply and calculate. Now you know how to deal with this type of L-shaped ones too, no?
Yeah.
Okay. Considering the theory of work, energy, and power. understanding very basic is extremely essential. Like,
It's the foundation of all
yeah,
the
that's the
calculation.
foundation. That's the foundation. Today in the morning, Jason missed that foundation. Yeah. He was looking for very big equation in there in the question. I didn't say. Actually, he managed to do the question paper within 1 hour, right? He actually finished like within 50 minutes. It's for a small question,
Okay.
a three marker. For a
Yeah.
three marker, he struggled for all 10 minutes. I only told him in the very last moment, this is the equation. He told me, sir, මානසික වැට්ටුව විනාඩි 10ක් විතර තිස්සේ. Yeah, I let him to go mentally a little bit down because why? If I said the stuff at the moment, he would get it. Now, firstly, I let him suffer, then told him, right?
Uh,
He will never forget now. This work done equals to force multiplied by distance.
yeah.
This was very happily there. He was finding direct power equation, weird power equation.
Uh,
Okay, now tell me what is the work done here? It is there. What is power? Power equals to work done over time, isn't that?
yeah.
Now, when you substitute this work done to there, what is it going to be?
And
Power
power
equals to
equals,
was multiplied by velocity. Because why? So, wait. Distance over time. You know what is
yeah,
distance over time?
P.
It is V. So, the equation is P equals to FV. He has forgotten this one. You should never forget the basic. If this one
Yeah,
is
one.
given, you have to be able to build up the next equation and go forward,
Mm.
right? Understood this one?
Yeah. So one second, I'll just write this down.
Okay.
Yeah. Okay.
Okay. Right. Okay. What shall we do? Okay. Now the next thing, energy. Energy is what ability to do work. There are two types of basic energy. One is the potential energy, while the other is kinetic energy. Now,
Yeah.
the force is weight equals to the mg, and the gravitational acceleration is here. The mass is m. So, what is the force work done here? Energy E P equals to work done. Work done equals what? Force multiplied by distance. What is force here? Mg. And what is
Mm.
distance here? H. So that's why potential energy equals to mg h. Got it?
Yeah.
Understood?
Yeah.
Okay. Now the next part. Kinetic energy. Oh, starting with U. I consider it like U equals to 0, certain condition. Right. At the moment, it begins to move and will all up to here. Right. Can you see all this?
Yeah.
Okay. There is a certain force applied on it. That's the force of F. The same force make it move there. And due to this force, according to Newton's second law of motion, there is an acceleration. Right?
Yeah.
And it may just make a distance of v. So, what is the work done here? Force multiplied by distance.
Yeah.
Okay, what is force for accelerating body? F equals to ma. Huh?
Yeah.
Right. Work done equals to MAD, MAD. Right. How to find out this acceleration? You have like certain things, but U is there and V is there. Acceleration is the one I would find, and the distance D is also there. What is the equation that you can use now?
V square equals U square.
V square equals to U square plus 2as. And this one is 0 now. What is the acceleration? V square over 2d, because S is D. Right?
Yeah.
Now I'm going to substitute it here. So I'm going to change the word that kinetic energy instead of word. So what is it? M instead of A, V square over 2D times D. Now D and D cancel so from each other. Kinetic energy equals to half M V square. Got you the answer? I makes sense. Okay. Yeah. Now the law of conservation of energy. What is the law of conservation of energy?
Energy cannot be created or destroyed.
Yeah, it can only be converted from one form to another. Right?
Yeah.
Good example is an object which is here, which would get fallen to the earth or wherever. With V at the beginning, U equals to 0, no velocity. So how about kinetic energy? It is 0. Yeah. Potential energy, we know it is like mgh, that is there. Here potential energy, 0, but the kinetic energy, there is the one, half mv square. So what had happened? The total potential energy converted to kinetic energy, right? So technically we can write it like mgh equals to half mv square. M to M cancel off. V is going to be what? Square root of 2gh. Got it? Yeah. And sometimes you may find questions like this. And there was a very good question. And I remember like I discussed like a 2 week earlier, this type of one. There was an object here with a mass of m. It just come to this point. So what is the amount of energy it has now? Potential energy. Isn't that? And what is the energy? Yeah. Now put it into process. Kinetic energy. Yeah. Now there is a, when the ball is rolling on this one, there is a constant resistive force likes of the friction. Due to this friction, this may ended up like a point like here after traveling, because once the work done against friction is equals to this kinetic energy. But you don't want to use kinetic energy because why? According to conservation of energy, potential equals to kinetic energy as well, right?
Yeah.
So you don't want to take this one as an intermediate. So you can get it like EP equals to work done. What is the EP? mgh equals to FD, right? There was a graph of what, as I can remember, like D versus V or something like a graph. So how to get D over V? D over H, sorry. I can get like D over H equals to mg over F. Can you understand?
Yeah.
Hello, Nikila. Okay. Understand?
Yeah.
Okay. It can be converted to any type. So this is also a possible thing. I show you something like a ramp and friction thing. Now how about frictionless surface? But there is a spring. And a plank here. And your ball is here. Height is h. Now, what would happen now? Adiluksan?
Oh.
It will just accelerate downward and gain a
Yeah.
certain velocity of v.
Mm.
Technically, it gains kinetic energy.
Yeah.
And again, I tell you, don't consider about that. It's an intermediate. The amount of earlier energy is the potential energy. That is the same amount according to the conservation of energy. I can just take this one quantity as EP. So I can just neglect this part and it will just hit this one. After hitting, what would happen? The spring get spring get compressed like this and make some distance of delta D inwards. Right? Yeah. After it's compressed, we get a certain distance like delta D. So I can take it like X. Okay. I am going to ask how to find out this X. Oh, if the X is given, what is K? Like this. Sometimes it may ask X, sometimes it may ask K, sometimes K and X all given, you may need to find out H. When the H is also given, sometimes you may need to find out M. The question might be anything. What is this one is the potential energy too. What type of potential energy? Elastic potential, right? Here is the potential, what? Gravitational potential. Got it?
Yeah.
So, gravitational potential is equals to elastic potential energy. Okay?
Mm. Yeah.
Okay, how it is? mgh equals to half kx square. You can find whatever the component they may ask. Might be m, might be h, might be k, might be h. Got it?
Yeah.
Shall we try a question then?
Yeah.
It's a really good question. Try this one.
Which question?
Yeah, this question.
Is this in the this thing you sent? Oh,
Yeah, the tube I sent now.
question 4.
Yeah, not the question 4. Question 4 double. Yeah, it's my bad. Printed double. So the first question 4. Okay.
Right.
Right. The speed of an air rifle pellet measures to be firing. So firing into wood block suspended from rigid support. Right. And this one is the one initially had the kinetic energy, no energy. At this moment, what is it has? It has the potential energy, isn't that?
Yeah.
The pellet of mass 8 grams strike the stationary wooden block and completely embedded in it. So the center of mass of the block rose by 0.863 meter. Right? The wooden block has a mass of 450. Then the speed of the pellet to strike the wooden block according to law of conservation of energy. You have right, like according to law of conservation of energy. If I
We
consider
have to
this
write
like,
like that.
half mv square is equals to m plus simple m gh. Okay, understand?
I wrote mgh equals half mv squared.
What mv? What about this one? This mass also stuck in that.
Uh, but okay, so sir, we have to take both
Yeah,
for.
impeded.
So I thought for this thing, for
No,
K, we only take the mass of the pellet.
no. This one is just together, moving together,
Okay.
right? Apply to the calculator like that.
Yeah.
And actually, you don't want to convert to grams to kilogram because in both sides gram there, so it will just get cancelled off. What is the speed you get?
Answer.
What is the answer you get?
1 second, sir. 25.38.
25?
0.38. Wait, sir, how do you have in the bottom part, what have you written? The denominator?
This part?
Yeah,
It's 8 because I just cut 2 and 8 and it makes like 4 here.
it should be. Wait, the bottom part should be 8.8 over 1000, no?
It's just 8 point, no? Or is it 8.8? Yeah. Can't cut like this. 8.8. So no need to convert, because why? In the top part, it is also 10 to the power minus 3. Right in the bottom part, also 10 to the power minus 3. These two components cancel off each other. So no need to convert here. Only for here. Because from
But
both
if you
sides,
put
it
it,
cancel
it's
out.
not wrong. Now, if you put on top and bottom, not
Yeah.
wrong.
No, not wrong.
Okay. So yeah, the 25.38.
Okay. Understand?
Yeah.
Okay. Diluksan, now I have to stop the class because I told you like around
Yeah.
6:45 I have to stop.
Yeah.
If you have any doubt, just drop me a text.
Okay.
Let's try to find out
So
another.
we'll do another. Now our paper is on Friday in Thursday class.
Yeah,
Evening.
let's try to fix another one.
Okay.
Bye, God bless you.
Thank you, sir. Bye. Good.